In the question, there are two circles, C1 and C2, and then we have the full details of this formula. So basically, we can get the center and also radius by the formula that we memorize. But the key point is pay extra attention here because we don't want too many variables. That's why we give a restriction is the coefficient of x squared and y squared must be 1. So our D and also E and F in any situation are talking about the same thing. So beware here, there is a little trap. This coefficient is not 1, and you have to make it become 1 in order to use this kind of formula. There are 3 statements for us to verify, so we have to get the full details. We need to know the center and also radius for each circle. We have to divide both sides by 2 to make sure that it fits to our theorem here. So x squared plus y squared plus 4 divided by 2, we have 2x plus 4y minus 149 over 2 equal to 0. It's ready to use the formula, so we can write down the center. Center is D, 2 divided by negative 2. E, positive 4 divided by negative 2. So which means it's negative 1 and negative 2. Radius is related. The radius is the center x coordinate square plus center y coordinate square minus the constant term. So we have negative 1 square plus negative 2 bracket square and then minus the constant term negative 149 over 2. Make sure you just substitute the things and then handle the sign later. It's give you square root 159 over 2. Just simply do the same for C2. This one's slightly different, that x squared and y squared coefficient is already 1, so it's just get ready to use the formula. So center is negative 8 divided by negative 2 and also negative 20 divided by negative 2. So therefore we have positive 4 and positive 10. The radius is equal to square root 4 square plus 10 square minus negative 53. So we have square root 169, which is 13. So it's enough for us to make the decision for each statement. So the first statement, the center of C1 is negative 1, negative 2, lie on C2. Basically, they are asking when x equal negative 1, y equal negative 2, is that fulfilling this requirement? If yes, if the outcome is equal to 0, then we say that it's lie on. If no, then we just say that it's not lie on C2. So we are going to consider when x equal negative 1, y equal negative 2 are in C2. Negative 1 bracket square plus negative 2 bracket square minus 8 times of negative 1 minus 20 times of negative 2 minus 53. Don't write is equal to 0 because we wonder, we are not sure at this moment. Oh, it's really equal to 0, which means that it's fulfilled this requirement. At that position, then left hand side will equal to right hand side. Therefore, we say that it's lie on. We accept the first statement. The second one, the radii of C1 and C2 are equal, are definitely not equal. This is much smaller. 2 is wrong. And then C1, C2 intersect at 2 distinct points. This one you have to draw different situations. So maybe C1 is like this, and then C2 is like this. We say that there are 2 intersect points. Or some other cases, the circle is here and then the blue circle just touch it. Then we have only one point of intersection. And the next scenario is a small circle here, and then C2 is further away. So basically what we are concerning the distance between 2 centers. Are they close enough to make them intercept? I let the distance between 2 centers be D. So D is talking about this distance. And then we want to compare the radius of our C1 and also the radius of C2. So obviously, in this case, R1 together with R2 is longer than our distance. In this case, R1 plus R2 is equal to our distance. And finally, this 2 center is too far away, such that the distance is larger than R1 plus R2. So let's get D here first and check which case we are talking about. So d is equal to square root. We apply the distance formula comparing these 2 points. X difference 4 minus -1, so we have 5 square. And then the y difference 10 compared with -2, the distance is 12. So we have 13 here. So it's also consistent with what we find in 1. Basically, you don't need this calculation. Just tell you the general procedure in case the center of C1 is not lying on C2. So in this case, because C1, the center is just lying on C2, therefore we must have 2 points of intersection. This is correct. Therefore 1 and 3 is our final answer.